calcium carbonate precipitate. Two-lift paving, again, you've seen this before. I think one of the things we often forget about is that when we construct the pavement in two lifts and you're putting down 7, 8, 9 inches of the lower lift of concrete, you've established a profile there with that, and placing the second lift on top, particularly if it's following by 20 or 30 minutes behind and that lower lift has started to kind of stiffen a little bit, makes for a very good construction platform, and the ride quality is often much better than when you build on that second lift. A little higher construction cost, and again, more energy consumed in the construction. Roller compacted concrete, again, potential for major cost savings, mainly in the materials and associated reductions in fuel consumption and greenhouse gases. Good ride quality for low-speed pavements, but may need diamond grinding or overlaying for higher-speed pavements, and that adds cost and possibly fuel and material as well. We're seeing a lot more use of wash water, concrete wash water collection and reuse of that wash water. This is a picture of a site down in Tennessee where we're doing that, and this reduces a lot of the problems with remediation and clearing drains when you're not doing this sort of thing. Eliminates the potential for localized vegetation kills when you're out washing the field and you're not confining it to a storage pit, and eliminates the potential for pH impact on local surface waters. Real-time profile measuring equipment. This is one of the Sharp 2 initiatives, and provides an opportunity for really closing that feedback loop on the quality of the ride immediately behind the paver versus coming back the next day when you've had another full day of paving done before you make a correction to the paving process or the mix design or whatever. So these are often laser mounted or sonic types of devices that are mounted immediately behind the paver and then provide real-time feedback to the operators on the quality of paving that's being done. Again, pros: better ride quality, lower vehicle operating costs and use phase. On the construction side, less need for construction corrections, less spot grinding and so forth, which means less use of fuel both during construction as well as use phase. Does have a capital cost of equipment, but I think there's a good move in this direction. We're seeing a lot of work being done with construction quality assurance now, with measuring dowel bars with non-destructive types of pieces of equipment like the MIT scan device. We're also measuring pavement thicknesses instead of doing coring. We're using non-destructive devices for that. The super air meter, which is out there now and is being implemented in many places, giving us a better idea of the quality of the concrete without having to rely just on total air content, getting a better indication of the quality of that air void system. And all those things assist then in the durability and the longevity of that concrete, which leads to hopefully better pavement performance. Texturing, again, Jeff mentioned texturing. We're trying to balance safety issues with surface friction and hydroplaning potential and reduced crash rates with the noise that sometimes comes with certain types of pavement textures. I think that the concrete paving industry has a real good handle on that these days with some of the longitudinal textures, the turf drag and the longitudinal tining and the very sophisticated diamond grinding processes that are out there now. So that kind of brings us to the end here, kind of closing out. Construction does have an impact on the energy consumed and the impact that we have both locally and globally on the environment. It may be relatively small in the grand scheme of things. I think that you see estimates that are maybe between, when you consider use phase, which of course is the 800-pound grill on the block, it may only be 3 or 4 or 5% of the entire life cycle. But when you look at the things that we really have a control over in design and construction materials, it may be more like 10% or so, or 15% of the things we typically control. There are a lot of opportunities there to adopt practices that will improve the sustainability of the pavements, and as engineers, the construction phase is one that we do have a great deal of influence over. We've gone over a lot of tools, some of the software that's out there. There are some tools available. Encourage people to take a look at those and dig into them more deeply. And obviously there's some potential there for using specifications and good construction quality for general overall approaches for reducing life cycle impact. And I think that kind of concludes my portion.
All right. Thank you, Mark. We appreciate that, and thanks to all of our speakers. This now brings us to the question and answer segment of our webinar. We'll try to cover as many questions as we can in the next 15 or 20 minutes. But if by chance we don't get to your questions, please feel free to contact any one of our speakers using the email addresses shown on the screen. So now I'm going to turn it over to Tom Van Dam, who will lead us through the question and answer session. Tom?
Sounds good, Kurt. Basically, we had some questions submitted, but if those of you in the audience still have more, there's time to get them in. I'll take the first one. There was a question on how low of a total cementitious content has been tried and proven, and then the follow-up was, are there any common issues with low cementitious mixtures besides potential lower strength? And I guess the first thing I would stress is it's all about optimizing the concrete mix with the aggregates that you have. And so a controlling factor is going to be the type of aggregates you're working with, their angularity, the type of sands you have. But there is a great website maintained by Tyler Lay at Oklahoma State. I honestly don't know what the address is, but if you put in like Tyler Lay optimize concrete mixtures in Google, it'll take you right to his website. I think it's called like Optimize Concrete or something like that. And there's a lot of tools available where you can optimize your gradation. And once you optimize that gradation, many DOTs are, well, not many, but some are starting to actually eliminate their minimum cementitious requirements. And that is true now in Texas. I spoke with the Colorado DOT last week, and they're considering the same thing. And so in places like Texas, with some of their aggregates, they're down to 423 pounds, I believe it is, total cementitious in some of their mixes. And so the limit might be somewhere around that. I've talked to people in northern states, such as Iowa. They still like to have a minimum cementitious content. I think they were kicking around 530 to 540 pounds total cementitious, but their concerns there were freeze-thaw durability, and they felt more comfortable with that limit. And so looking at context, looking at your aggregates, the key here is to do experimentation, and I think you will find that that you can significantly reduce it off of what we thought that we could. I'm going to move on to a question for John. Let me get down there. Basically, the question was, could he comment on how pavement use location affects sustainability? For example, highway pavement, airport runway pavement, port terminal, yard pavement.
Well, thanks, Tom. In terms of the different applications which are shown here, I think a big thing that will affect it in terms of your design considerations is failure criteria, different types of materials that you can use for each of these different applications. Those are some of the main ones. The other thing about pavement use and location has to do with different climate regions, which affect different failure mechanisms, different subgrades, different availability of different types of materials, and whether you have to transport materials very far. So those are some of the other, not so much on the application, but on the location for a given application that can affect the sustainability. I think one of the biggest ones is the availability of different material availabilities, and then the climate effects on performance. Traffic levels is the other. Sorry, the other big one is traffic levels, and whether the materials and construction phase is more important than the use phase with regard to vehicle use. So that's another major consideration.
It does sound like context is very, very important.
Yes.
Jeff, I'm going to throw one your way. How much diamond grinding, you talked about the impacts of diamond grinding, how much do you feel can be done before the structural capacity of the slab is negatively impacted?
Jeff's pointing at me here. So I think I'm going to answer that one, if that's okay.
Perfect.
You know, typically, at least historically, when we've designed our concrete pavements, we have not considered the long-term strength gain of the concrete. You know, we designed for particular strength. And there's been a study that was done, it's probably 10, 15 years ago now, and I couldn't even tell you what the citation is now, but I got a copy on my bookshelf, and I'm sure, again, Google, the magic tool, go out and look for diamond grinding structural capacity or something. But the report came out and said that you could essentially, over the life of the pavement, diamond grind up to 3 times and not significantly impact the performance life of that pavement, because our design procedures were not taking into account the long-term strength gain of the concrete. So if you look at the fact that a typical diamond grinding operation removes about 2/10 of an inch of material when you're doing the entire pavement surface, you know, if you got, you know, particularly if you got 10, 12 inches out there, I don't think you worry too much at all. When you're really thin, I think the impact is greater. Go back to your basic structures and you think about the fact that the stiffness of the pavement, the load carrying capacity, is essentially a function of the cube of the thickness. So if you're taking off 2/10 of an inch off of a 10-inch pavement, you're only reducing the thickness by about 2%. You know, and if you offset that already with a big strength gain, it's practically nil. So bottom line is, I've not ever heard of anybody say that they diamond grounded to the point where it reduced the structure to the point where it failed. If the diamond grinding is done on a normal interval, it should have no significant impact at all.
All right, and I was going to actually go to John real quick on that, because in California, I know there's been pavements that have been diamond ground at least 4 times. John, have you ever had heard any experience where the diamond grinding may have somehow shortened the life or has had a negative impact?
The grinding definitely makes things smoother. The impact on the cracking performance is very hard to tell. I can't think of any case where there was a rapid increase in cracking that could be directly attributable to the grinding.
Okay, well, good. I'm going to switch now. I'll try to get one to Jeff again here. Maybe Mark will take this one too. I don't know. Well, we'll see. You know, both you talked a lot about the Illinois Tollway, and I know that you've done a lot of work for them, Jeff. A lot of the techniques that they're employing are fairly innovative. What do you attribute their embracing of these innovative technologies in such a rapid way? I mean, how did the Tollway approach it that they've become comfortable with doing some of these things?
Well, I think a couple of reasons. They've been wanting to take the lead in sustainable practice, and they've got many research projects that are way ahead of some of the things they want to implement. And so they have that, and they have consultants who are implementing what the research is finding right behind them, and they're willing to do small test sections. As an example, the 2-lift paving, they first did a ramp relatively quickly to test it out, a small ramp, a composite pavement. Then they did kind of a service road of a 2-lift and looked at the 2 pavings as a test section. Then they did a mile section on one of the projects one year, and then finally they implemented on a mega project. So it wasn't the first time they tried it, but I would say this was like a 4-year experience where they had researchers, consultants, contractors, and the agency really pushing to implement sustainable practices. And so, although I think they do a very good job of not letting research results sit on the shelf.
Excellent. Did Mark or John, did you want to add anything on that?
Not really. I think sometimes when you get a tollway, which is a kind of a quasi-private authority, maybe they aren't quite as hamstrung by policy as many DOTs are. I know my experience in Pennsylvania has been the turnpike, similar to the tollway here in Illinois. The turnpike is willing to do things and able to do things more quickly because they don't have quite the policy structure, I guess you'd say. They're it's a different organization.
I think there are moments of opportunity for implementation. I think there's a balance between moving ahead quickly and potentially moving ahead too fast and encountering unintended consequences. So I would kind of counsel, I mean, this sounds kind of wishy-washy, but I would counsel really evaluating something and then making sure it's the right thing to do. And then there's really moments of opportunity, which are often political, or a change of personnel or something like that that allow you to move forward when you're dealing with a bigger organization than a tollway or a turnpike.
Okay, great. I'm going to go to another question for myself, and the question is an excellent one. It's really how much energy is used to produce calcined clays, and or this type of natural pozzolan. And there is an answer to that question. And if I wasn't doing my webinar here, I probably would have Googled it. I don't know the answer per se, but I do know that most calcined clays are produced by taking the clay and running them up to about 700 to 800 degrees Celsius, I believe. And so there is energy consumed in obtaining the clay and excavation and processing it and in heating it to about half the temperature that we would go to in a cement kiln. And then, of course, in post-processing that material and getting it shipped out. So the thing to realize here is anything that we do, such as calcining the clay and then processing, consumes more energy. And so it's going to have a higher energy footprint and greenhouse gas footprint than would be a natural pozzolan that is just excavated and, let's say, ground. And so all of those things do get tabulated when we should be looking at mixes. So we're making these choices through like a life cycle assessment, and I believe that's going to be a latter webinar. I won't get into more detail, or maybe we already did that one. But you talk about the accounting of the energy and the environmental impacts that go into all of these processes. So calcined clays are not free of environmental burden, but they definitely will have half the energy consumed because of they only go to about half the temperature, so a lot less energy than a cement kiln, and then the processing is a bit easier. So I know it wasn't an absolute answer to your question, but hopefully it at least got halfway there. And John, I don't know if you have a better idea on calcined clays, what their footprint might look like.
I don't.
Okay. So moving on, I think I got another one for you here, John. It goes back to your slide 45, and so maybe you can remember it or you can pull it up quickly. It shows major rehab replacement for a 20-year design at year 35. But the 40-year design doesn't show a major rehab replacement until year 85, which is more than twice the design life. So the question is, it seems the definition of pavement life is quite different for the 20 and 40-year designs. How did you define design life in the context of this slide, or the work that was done?
I actually scrambled back and found the original paper to remind myself from about 10 years ago. So the way this was done, of course these are simulations, but the way this was done, the 20-year design life is about an 8-inch concrete slab. The 40-year design life was about a 12-inch concrete slab. And the way these maintenance and rehabilitation scenarios were put together was using MEPDG to estimate the cracking, and then applying CPR based on the cracking levels until we reached the level at which the Caltrans maintenance and rehab guidelines would indicate that we needed to go to an asphalt crack seat and overlay. And then from that point forward, you're doing updating that asphalt overlay. So the real difference why the 20-year design life needs that asphalt overlay at about 28 years and the 40-year design life doesn't need it till much later is the rate of cracking predicted by MEPDG, which is primarily a function of the slab thickness here. So that extra hit in global warming potential is that extra 4 inches of concrete primarily, and the tiny part associated construction, but it's mostly the cement for that extra 4 inches. But what that extra 4 inches gets you in this case is a much slower rate of fatigue cracking. and therefore that pushes out the crack seat and overlay a tremendous amount. And that's kind of one of the things, a general principle of longer life pavement design, whether it's concrete or asphalt, is that there's generally a nonlinear effect of increased thickness on cracking life, in that a unit increase in thickness will give you more than a unit increase in cracking life, because the stresses and strains that cause cracking are reduced by a factor of thickness to the third. So that's getting a little technical there, but the basic takeaway is that thicker typically gets you a bigger percentage bump in fatigue life than the percentage bump in thickness itself.
Got it. I got one more question, I think, and I'm going to direct it first to Jeff, and then Mark might want to also weigh in. And it has to do with the recycled concrete. We saw a lot of examples, and I think we covered it pretty well. But when we're looking at a concrete pavement system, what do you feel is maybe the most effective way to use recycled concrete aggregates?
Well, I mean, from what we've studied in Illinois, from the tollway, the airport, I mean, the easiest way to minimize handling is going to be as a crushed sub-base material, porous granular embankment. You're going to minimize the handling of it and the hauling distances, and that really lowers the cost. Now, work we've done at the airport, you know, they may not have a need for that there, and so then they look at other applications like using it in a stabilized material. But there you have limited hauling distances. So, but generally in Illinois, in our experience, there's very little demand to actually need to use it in anything other than a sub-based material, because they can use it all up usually on a project.
And Mark, did you have any maybe different experience or anything to add?
No, I wouldn't disagree with anything that Jeff said there. I think that it's always good to use it into a higher application if you can, and if there's a place to do it. And an effective way to do that may be, you know, as we're going to these two-lift pavement systems, to use it as a coarse aggregate, maybe even a small amount of the fines. And what we have a hard time with crushed concrete is finding a good place to put the fines, because we can find all kinds of good applications for the coarse material. But depending on the crushing process that you're using, you may produce a significant amount of fines. We can do a little bit of replacement of the fines back into the concrete mix beneficially, I might add, even, because they tend to kind of fill in a part of the total aggregation that is often missing in the aggregates that we use. Bases are certainly the easiest way to go, and I think that all the excess fines got to go into filling into base applications and stuff down below a drainage layer. But if you have the ability to put the crushed coarse aggregate back into the lower lift of a two-lift paving, or into a cement-treated base of some sort, because the aggregate quality merits it and so forth, then certainly from a sustainability standpoint and the materials use standpoint, that makes sense.
Well, that sounds good. I think that's all the time we have for questions. Kurt, I'll turn it back over to you.
All right, thank you, Tom. Yes, that does conclude our webinar presentation for today. I'd like to thank all of our speakers once again, and I hope all of the participants found the webinar interesting and informative. Once again, you may contact any of the speakers at the email addresses shown on the screen if you have any follow-up questions, and you may also contact Gina Ahlstrom or me if you have any general comments on the layout, format, or contents of the webinar itself. So with that, thanks again for your attendance, and we leave you with a reminder for the final two webinar events that are scheduled to be held in August and September. We hope you'll be able to join us then. So long and have a great day.